Okay, welcome to the Friday seminar series for Friday the 13th. This week we are continuing in our theme of looking at transportation models and trying to explain all those complexities to the lay population. So we have another esteemed speaker this week, Ben Stabler, who is the Transportation Systems Planner for Parsons Brinckerhoff. He brings a wealth of experience both working on local and national models as well as internationally on transportation, activity, and land use modeling systems. And I think I'm going to save most of the time for him to speak to you. So he's going to talk for about 45 minutes, and then we'll open it up for questions. I'm going to remind you, as I will every week, that when you talk, please use the mic at your table, and if it doesn't work, to cue me. Thanks.
Okay, thank you. Thanks for having me. So I'm going to talk today about travel models, try to introduce them. Some of the material might be a little introductory, some of it might be a bit advanced. It kind of just depends. I tried to blend a bunch of different things together and just kind of give you an overview of some of the things in travel models, some of the advantages of different approaches, the disadvantages of different approaches. So it's kind of a mix of stuff. So hopefully it works out pretty well. All right, I'll talk a little bit about the inputs to a travel model that are generic to two different approaches, and then I'm going to focus mostly on four-step travel models, which is the models that are used in practice for the most part, and then also the next generation models that are being developed, activity-based models, and then provide a little bit of discussion about them. So a travel model, I think it's good to define a travel model or just look at a system to start with what goes into it. What are the inputs into it? So in a travel model, we need geographic data. We need a description of the road and transit network, so something that describes the highway network, the transit system, the bus routes, the roads, the intersections, all that information in the GIS gets put into the travel model. So it's in a whole bunch of different forms and different models, but the basic idea is a description of the road and transit system. And then also, we're going to divide the whole region into a series of TAZs, traffic analysis zones, or transportation analysis zones. But basically, we're going to take like the Portland metro region and cut it up into districts or zones. Sort of like census blocks or census tracts. But they're going to be areas where travel is going to come and go. All right, sources and sinks for travel, or origins and destinations for travel. And these are supposed to be homogeneous areas, areas that have same type of land use, maybe similar types of demographic characteristics, same types of household incomes in those areas, because those are going to be our spatial units of analysis for the model. We also need to put in a bunch of demographic data. So what we're going to do is we're going to model travel as a function of household demographics or person demographics, also employment, things like that. So we'll take from, for example, we'll go to the census data and gather up information from the census about the households in the area and try to figure out how many households are in each zone. So 100 households are in this part of town, 100 households in this part of town. And not just how many households, but what are the characteristics of those households? What are the households' income? What is the size of the household? Things like that. We're going to focus primarily on household-based travel. So households are going to generate travel. And one of the main things that attracts travel is employment. So we also need to put employment into the model. So we need to put in different types of employment, retail employment, industrial employment, all sorts of employment. And that comes from various sources. That'll come from state employment data. It'll come from land use forecasts like Metroscope, one of the tools that's used here in Portland. So different types of demographic data. So we're going to attribute the entire area with the types of households that are in certain areas and the types of employment. So we have a description of the system, the supply, the travel network, all right? And then we have travelers and the information about them, the demographics. One thing we're going to need also is survey data. So we've got all these people, right? And we have a travel network, but we don't know how they use it. We don't know where they go. We don't know how often they travel, things like that. So a survey is done, a household travel survey. And I have some more slides on this stuff. But in a travel survey, basically you keep a diary. So you'll get recruited for a travel survey, and you'll keep a diary for like a day, maybe 2 days, your whole household, everyone in your household. And you just write down everything you do. You know, I got up at this, you don't say when I got up, but you start with like, where were you at 3 o'clock in the morning? All right, so you say, usually I was at home. And then I went to work at 8 o'clock in the morning. I drove, this is where I work, this is the car I took, et cetera, et cetera. So from that, then we can estimate statistical models and say, people on average make this much amount of travel, or people tend to go to these locations, things like that. And then also one of the other things you need is traffic counts. You need information, because after we build this travel model, we're going to take all the travel and we're going to put it onto the roads, and we're going to develop estimations of how much volume is on each road. And we want to compare those to what we have in reality, which is the traffic counts in the base year, in the model year. And see, then we can validate the models and see how well they do, and say, we seem to be low on freeways or high on certain types of intersections or whatever it might be. So let's look at some of these in more detail. So the travel network is the supply side of the model. So what that means is we're going to generate demand. Okay, that's travel. People's travel, that's demand. And supply is the system that the travel uses. So in sort of a supply and demand type framework, we're going to have a network that can handle so much demand. And as a result, sometimes there's too much demand for the amount of supply that's available, and so you get overcapacity situations or saturated situations, which is congestion. And then people choose different routes, or maybe they go different places to shop or things like that. So it's that interaction between supply and demand. And the network really represents the supply side. I'm not going to talk too much today about network processes. I'll focus more on demand. But one of the things the network's used for is to generate level of service indicators. And so that's basically like travel times. From the travel network, we can get the amount of time it takes to get from one location to another, right? So the time to drive through the network or take a bus through the bus system. So you're familiar with Google Maps, right? And you can choose, it'll do your directions from an origin to a destination, and you type in the address of the origin of the destination. So in a travel model, we do that for like millions of combinations. It's sort of like running Google Maps for like 4 million times, 2,000 zones in a model, so from all 2,000 locations to all other 2,000 locations. So that's one thing that the model does, and that gives us then travel times between every location, or travel costs, or distances, or fares if we're taking the transit system, the costs between the origin and destinations. These are also called skims. You'll hear that sometimes because those indicators are skimmed off the network. It's kind of an old term. And we do this, we need these indicators for all types of modes. So we need them for SOV, like drive, single occupancy vehicle, for HOV, like carpool lanes. We need those for transit, we need those for bike, we need those for walk. So we need an idea of the amount of impedance or cost or time to get from one place to another for all the different modes. Because in a travel model, I'm going to try to choose what type of mode, for example, when I go to work, which type of mode I'm going to use, and I need to know what the available choices are and the costs of all of those choices. And also for, different types of modes like bus rapid transit and things like that. So the network, how does a network get built? This is a simple little model area. And we take all of the roads in the model area and code those up in like a GIS. And all the intersections become nodes. And then we draw links, which are called links, lines, polylines between all of the nodes. And that becomes the travel network. And each one of these links gets attributed with like a speed, like a travel speed, posted speed, a free flow travel time, meaning the time it takes to drive the link if you drive it at the posted speed, and other things, other attributes that are important. And that's the network. And the transit system is coded up as well. So this is an example of a transit network, just bus stops and links again to connect up all the bus stops. And then the TAZs, we're just going to define different areas of the city, basically, and cut them up into homogeneous areas. And so you try to cut them up so, like, you know, the houses are in one location and maybe the employment is more in another area. It gets a little more complicated than that, but that's the basic idea. So the whole system gets coded up with that. So, you know, in the Portland region, there's around 2,000 zones for the metro, the Portland metro model. I can't remember how many links now, but maybe 20 to 50,000 links. And I mentioned the travel survey. So this is just an example of the diary. And, you know, what we do basically is you record everything you do. This is just a diary of your sort of like your life for the day, all your travel. You know, where were you to start the day? What time did you arrive there? How did you get there? What travel mode? You know, if you drove, then what car did you take? All this information. Did you pay for parking? You know, what time did you leave? All this stuff. So from that travel diary, we can then estimate models of the number of trips people make, the purposes of their travel, whether they travel for work, you know, how often in the data do they travel for work as a share of all the travel they do on a day. How often?
How do you get people to do those? You know.
Yeah. So. There was one recently done here in Oregon. So a random sample of people is generated, and then they call them up and try to recruit them. And they also provide incentives, so you get like $50 to do the survey. The response rates vary with different populations and stuff, but it really is the key data source to build a travel model, because it connects everything up. It connects, you know, different types of households with what kind of travel patterns they have. So those are the main inputs that go into the model. So let's talk a little bit about the 4-step model. The 4-step model is the traditional model that's used all around the country, most around the world, and it's pretty much at every MPO in the country. It pretty much has to be, and it's also at a lot of not smaller MPOs like 20,000, 30,000 type, you know, areas. In Oregon, I think they build models. ODOT builds models for like 5,000 population regions and above or something. You know, they might have models a little bit smaller, but for the most part, any city about that size or bigger has a travel model in the state of Oregon, and that's a 4-step model. And in a 4-step model, the first thing we do is we generate trips. So we decide how many trips are produced in each one of those zones. And that's going to be something simple, like take the number of households. Let's say there's 100 households. And from the survey, we learned that a household makes 10 trips on average a day. 100 households times 10 trips a day is 1,000 trips that are going to be generated from that zone. That's all that is. There's fancy versions of that where we segment it by different types of households, high-income households versus low-income households, because high-income households travel more. Households by size, larger households have more travel, etc. But that's the basic idea behind it. In a trip distribution step, so this tells us how many trips are produced in all the different areas. The distribution step is it takes the trip productions and chooses destinations for them. Okay, so we're going to say that, you know, a certain amount of work travel is generated in this area where there's lots of households, and downtown there's lots of employment. So we're going to develop a model to send those work trips out of those households to destinations to work, and they're going to be very largely attracted to where there's lots of employment. Okay, now that's simplified, because it's all stratified. So different types of employment attract different types of workers, different types of household incomes go to different types of employment because they're doing different type of work. But that's the basic idea. And the likelihood of choosing a destination to work, for example, is not just based on the employment and the size of the how much employment there is, but also on the impedance to travel, right? So if it's very far to go, you're less likely to go there. But if it has a lot of employment, then maybe you'll go a little bit further, right? So it's this trade-offs between travel impedance and attractiveness or employment. The mode choice model. All right, so after we've chosen a destination for each trip, and we'll do this for work trips and shop trips and recreation trips and other types of trips, we choose a travel mode for those trips. So at the first step, we don't really know, and it kind of depends. There's all sorts of models, so sometimes more or less, but the basic idea is at that point we don't know the mode of travel, and in the mode choice step, we choose a mode for those trips. So we're going to choose whether they drive to work or they take bus to work or they walk to work, or we do that for all the different modes. And that's a function of a number of characteristics of the mode. The travel time, the travel cost, all sorts, for transit, the fare, the walk time to the bus stop, the walk time between stops if you transfer, the egress time from when you get off the bus and walk to your destination, things like that. Various levels of complexity depending on the model. Some models are quite simple. Some models are a lot more complex. There is a step 3.5 that's kind of always forgotten, but this is primarily done at the daily level. All the travel is modeled on a day, and then we split the trips into different time periods. So then we say this share of the travel happens in the PM peak. Let's say 10% of it happens in the PM peak. All right, those are time of day factors. Those are kind of a troublesome spot in 4-step models that the activity-based models do a lot better job modeling. And then the final step then is to do the trip assignment, and that's where after we've chosen a destination for the trip, we've chosen a mode for the trip, then we'll choose a route for the trip. All right, so if it's a bus trip, for example, like a transit trip, we're going to choose between maybe taking the MAX for part of the trip or taking bus, all the way. So a picture of this, in a trip-based model, we will have a production zone, like home zone, and we'll have a home-based work trip, which means it's a trip that originates at home and is attracted to a work location. And then we're going to have trips, so we have work trips. We also model home-based other trips, which are trips that are not work-related, but are to other things like shopping that are connected to home locations. And then we also model non-home-based trips, which are trips that don't originate or end at home, just sort of like extra trips you make during the day, for example, like work trips or shopping trips, lunch trips, things like that. It's kind of confusing, and it's one of the worst parts about a 4-step model is these sort of non-home-based trips and things. It'll be clearer in the activity-based model, and I'll talk about that in a few minutes. But this is a non-home-based trip to lunch, for example, and whatnot. So I'm not going to go through how this is all set up, but a trip-based model just works with these types of trips. It does accounting to generate a number of trips, distribute those to locations, and work through different types of trip purposes. So, for example, in trip generation, we'll have 34 trips produced from Zone 1, and we're going to choose destinations for those. So we're going to go, 27 trips are going to stay within their zone, 7 trips are going to go to Zone 2. In the mode choice step, we'll take those 55 trips, for example, and we'll assign 30 of them to auto and 25 of them to transit. And then of those 25 transit trips, we're going to put 18 of them on Route A and 7 of them on Route B. One of the things that's important in this is the trip-based modeling framework is very matrix-based. So we're often working with matrices that are from zones to zones. So after we take all the, so let's, for example, we'll take all these trips that we generate, and we'll say we have 5 trip purposes. We will generate 5 sets of matrices, trips from all the origins to all the destinations for the 5 different trip purposes. And then we're going to take those 5 trip purpose matrices, and let's say we have 5 travel modes, and we're going to split those into 25 matrices. All right, so the 5 work trips now are 5 work trips. The work trip matrix is now going to be 5 work trip matrices, one for the drive, one for the transit, one for the walk, one for bike, etc. So we're just like generating more and more of these matrices. We're taking all the travel and we're cutting it finely as we can into all of these different dimensions. The dimensions are origin, destination, mode, time of day, household market segment. And so we've cut this very thin. And sometimes it just gets kind of overwhelming to the system to keep cutting it like this, because a priori we've said that there's different characteristics of household types, like incomes and then trip purposes and all this stuff, and we split these matrices and define them. The activity-based model kind of frees us from that thinking, which is really one of its benefits, because eventually you just get so many of these matrices that, one, either you have very little data in each cell, so it's hard to really get good results from the model. 2, it becomes computationally expensive because there's just so many of these matrices that have lots of sparse, very few values that it's kind of a huge amount of data, but a lot of it's empty and it's slow. And so an activity-based model is a great improvement over this type of approach. So some of the nice things about trip-based models, and I'm sure some people might argue with this list a bit, but trip-based models are aggregate models. They're working with just like all these matrices are just like a market segment. The amount of work trips from a certain area to a certain area, and we might even have decimal numbers. We might have 32.7 trips, work trips, from one location to another location for a certain mode. So it's it's very aggregate. So when you get all the way to the end and we put all this travel onto a network and we've chosen routes for these people, we get a number like 1,200 people are on this road, and our traffic count says 1,000. Sometimes it's difficult to go back and figure out who exactly those 1,000 are, why are they on the system, where are they going, what's the age of those travelers, things like that. So it's good for sort of generally looking at highway build projects and things like that, where we maybe don't care as much about who the travelers are, but it gets difficult when we want to then look at the individual characteristics of those travelers, and also look at more complicated policies than just building building projects, for example. There's no randomness in these models. There is in the activity-based models. You'll see that coming up. So you run it and you get the same results every time. And you can run an activity-based model and get the same results every time, but there's some randomness that's seeded into the process, so that if you change those random seeds, that's probably too much jargon, but if you change those, then you'll get different outcomes in the models. These ones are modeling the average behavior as opposed to drawing from a distribution of behavior, and so there's you always get the same number, but it's sort of hiding the variability that's inherited in the system. There's not as much data required to build these models in the activity-based models. They also run faster. They're quicker to build. They're used pretty much everywhere. But the activity-based models are rolling out in different places more and more every year. Some of the problems with trip-based models, behavioral fidelity is a big problem. We decided, for example, so we look at this survey data, and we're going to say that 10% of travel happens in the PM peak, right? And so it's totally insensitive to anything. It's 10%. So in the future, when we change the system or there's more congestion, we're still going to say that 10% of the travel happens at that time. But instead, we should probably build a model that says people, try to avoid congestion. People will shift and go to work a little bit earlier or come home a little bit later. We can do that in an activity-based model. It's much more difficult to do in a trip-based model. There's a lot of aggregation issues. The non-home-based trips, the trips that don't happen at the home location, don't start or end at home, they're kind of a messy part of four-step models, and we don't have a lot of information about them and why they're created and things from the survey. So there's problems with those trips. The zones maybe are big. The spatial aggregation, the market segmentation. If we're going to cut all of these households into incomes and size and workers and all these different categories and build all these matrices and then build lots and lots of them, we can't do like just we can't just make tons and tons of market segments. It just becomes way too much data and too complicated. So we group those into categories, and later on, it turns out that when we look at the results, we want that information back. We want to be able to look at person age of travel, and it's difficult to do and when we have to ahead of time define all those matrices. And other problems with trip-based models, there's, like I said, time of day isn't modeled very well. There's time of day shifting. There's certainly a lot of improvements that can be made to modeling accessibilities. So that means different types of accessibilities, whether it's like walk accessibilities, so that in a trip-based model, sort of make broad assumptions about how easy it is to get to the bus out of your zone, or can you walk to certain locations and things. Activity-based models are more and more kind of dropping some of those assumptions and not doing things so general, and so they have much improved accessibility type measures. They're modeling accessibility a lot better, and that's similar to land use interactions. So just to give you some ideas, so as I kind of mentioned this first one already, so I'll skip that one. But in a trip-based model, for example, let's say that you have a managed lane that operates different in the AM and the PM, right? So it's like like an express lane, maybe that's open in the AM one direction, and in the PM is open a different direction. Well, a lot of times in a four-step model, the model that chooses destinations only works off the AM level of service indicators. It only looks at the AM network. It doesn't know anything about the PM network, in which the lanes changed and the travel times are better. So in a trip model, there's no connection between the outbound trip and the return trip. All those trips are modeled independently. It just generates them. It just says there'll be 10,000 of them. It doesn't say there's 10,000 of this kind and 5,000 of this kind, and these 5,000 are related to those other 5. They're the return trip. There's no concept of that. Activity-based models have those concepts. And also, equity analysis is another issue. I talked about the segmentation. As we define all these matrices, right? So we just cut the households up into different types of. We're going to generate travel for different types of households. Well, maybe we segment households by the number of autos they own, because they have much different characteristics for travel mode, for example. People with more autos are less likely to take transit. Well, if we do that ahead of time, then we're sort of stuck with always looking at problems through households by number of autos. And then we get down the road, and people don't want to just look at households by number of autos. They want, or travel for households by number of autos. They want to look at travel for single-parent households. That information's gone in a four-step model. It's just that's just an impossible concept, because it doesn't keep all that information along the way. So it's kind of hard to explain, but let me show you some more examples. So let's talk about the activity-based model a little bit, because it's a different way of looking at the problem. How am I doing on time? 12:30, okay. All right, so in an activity-based model, the important thing is that we're going to look at how people decide to travel, whether they decide to travel, where they decide to travel, when to travel, and how to travel. We're not just going to look at the data and come up with like rates for all this stuff and then just generate a bunch of travel. we're going to build more predictive models to look at this information. So we're going to change the way the model's built a little bit. We're going to model individuals. In a trip-based model, we model households. All right? So we're just going to generate the amount of travel for different types of households. So we don't know anything about the persons in those households. We know a little bit. We'll say that this is a high-income household or this is a 3-person household. But we don't know anything about those 3 people. And then when we go to put them onto the network to have them choose a route, for example, we don't know that that person is, age 38 or that person is age 64. That information's lost. So once we have that micro level information about everyone, then we have much smarter models because we have so much more information about them. So we actually it's called micro simulation because we model every person. And we're going to model trips. So in the previous model, we just modeled trips. Right? That was all we did. We just generated a whole bunch of trips intelligently, but as best we could. But in a activity-based model, we'll generate tours. So we'll generate a work tour. So that'll be how often do I'm going to go on a work tour, which means go to work and come home. And it also can mean go to work, stop on the way home for dinner, stop at the grocery store, stop at home. That whole thing. The nice thing about modeling that whole thing is we can learn things along the way. Or we don't learn things. We keep track of that information so that when I'm at work, I know where my home is. I know if, how long I've been at work, so I can decide when I'm going to leave work. On the way home, when I'm going to the grocery store, I can know where my home is, where my work is, because the grocery store is probably going to be fairly close to along the straight line distance between work and home. So there's information that we can use when modeling that whole tour about the other parts of the tour to make better decisions to model the trips along the way. And the other important thing is we're going to model consistently people's behavior in time and space. And so we're going to basically schedule, and I'll show you this here in a sec, we're going to schedule like primary activities or mandatory activities first, like work and school trips, because they tend to anchor your day, and then sort of fill in all the extra stuff around them. Right? So we're going to, in a hierarchical fashion, look at travel, as opposed to in a trip model, we just generate all that independently of each other. So it totally different types of data then, because the work travel has nothing to do with the shopping travel, but that's not how people behave, right? A lot of times travel is, sort of anchored by key locations, work and home, and then shopping and other things are sort of filled in around that. So activity-based models are sensitive to a whole host of other things that trip-based models are not. About time use, equity, they're much better at pricing because people have much different values of time and sensitivities to different prices. So we can model pricing. If we're going to price a facility and we're going to look at different cost scenarios, a toll of $2, a toll of $4, whether people have transponders or not. We can look at that type of information because we have every person in the model now, and we have their own sensitivities to prices and things. Oops. It's also easier, I keep pressing forward instead of the pointer. It's also easier to integrate with improvements in traffic assignment models, and if you're familiar with dynamic traffic assignment, it's basically much smarter ways to find routes and things like that. It's much easier to integrate those things because those are much more likely to be micro-simulation models, just like an activity-based model, individual people. So in a dynamic traffic assignment, individual cars or individual travelers and other policies. So in an activity-based model, the key thing to do is generate a synthetic population. This is the key thing. In the trip-based model, we put in the number of households and the number of employment, and then we took those households and multiplied them by trip rates to start generating travel. An activity-based model, we actually go to the census data, the public use microdata sample, and that's just a record of a whole bunch of census data of individual answers on the census long form, or different types of forms, but basically individuals, households, and then all the individuals in there. So this is a PUMS household file, so there's a bunch of households, and then the size of the household, the income, the number of workers, the age of the head of household, things like that. And we're going to draw a whole bunch of these records to generate a synthetic population for our region. So we'll go and get like the 10,000 PUMS records for Portland, and we'll create 3 million households by sampling from those households. So we'll take a record and we'll use it 50 times and create 50 households. And we do that, we pull from that PUMS data in an intelligent way. We do it so that we're, what we say, controlling for different variables. So if we want a certain number of high income and low income, we only draw enough to match those totals. Yeah, it depends, yeah. We'll draw based on household income, size, number of workers, gender. It varies, just depends on the model. Yeah, based on some controls, some targets, some totals. So now we have a population of people and households, right? So now we can just generate diaries for them. Remember we saw the diary earlier? We're going to just generate a diary for everybody. That's it. That's all the activity-based model does. So it goes through the 3 million persons and generates a diary. So the model isn't going to treat every single person completely independent, because there'd be way too, the statistical models would be too big. So we still have to group people into certain types. Just like in a trip-based model, we grouped households by income. We're going to, in an activity-based model, group persons by persons types. But we have 8 types of people. We have full-time workers, part-time workers, different types of students, kids, whether they drive, things like that. We have ages for them. So we have a lot more information that we can use to describe people's travel. So, and talking about trips and tours, in the trip-based model had all these different types of trips. In an activity-based model, we're going to generate this work tour, and then we're going to generate this work-based tour, and work with these units, and then fill in information along the way about the tour, the different pieces of the trips, but with knowledge about the whole tour, much more intelligent. And the nice thing is the data is going to be like a database, like a table of data, where each record is a person, and then each column is going to be additional information. So it'll be like how many trips they made, where their work location is, and then how many trips or how many tours they make that day, and then how many trips on the tour. And so we're working with tables of information as opposed to these matrices. We can also do things when we have tours. We can also ensure things like mode consistency happen. If you take the bus to work, you can't drive your own car to lunch. That sort of happens in a trip-based model. It doesn't really happen because we don't know anything about any of the trips. The trips don't know anything about each other. Okay, so, but we can't say it doesn't happen because we're not actually explicitly modeling tours and saying, okay, you're at work, you don't have your car, therefore when we choose a mode for your work trip to go to lunch, you can't choose auto. You can only walk or bike or take the bus. We'll skip that. Run out of time. We're also going to model in an activity-based model time a lot different. So in a trip-based model, we tend to look at very aggregate types of time, just different time periods like a peak and a midday time. But in a activity-based model, we'll often split it into half-hour increments. So when we choose the time, like in the 4-step model, I said we have these factors, right? Like 10% of travel happens in the peak, regardless of what the model, regardless of anything. It's an input. It's 10%. It's a little more complicated than that, but that's the idea. In an activity-based model, we will have a time of day model that's going to choose the time to leave for work, the time to return for work, and it's going to look at half-hour windows. So we can then model, you'll model travel from 9:30 to 4:30 and 10 to 5 and 10:30 to 5:30 and all sorts of combinations of half-hour windows. So it's much more precise. And that's very important if we're looking at like pricing problems. Like if we get very congested peaks and we want to price the peak so that people will not drive in the peak, they'll leave for work late or leave early. We have to have that temporal precision in order to move people into those windows. If we don't have those in a trip-based model, we can't as well really answer those types of policy questions. We're going to skip that. So an activity-based model models just individual records. That's really the important thing that I'm trying to get at. And so this is just one of the things we put together is just to trace individual records. So this is a person, and it's just saying where they in the simulation in the model, their home location, their work location, telling you a little bit about when they're leaving to go on these different trips and how long they take and stuff. Now we'll generate like 3 million of these. Each individual one of these is very random. You can't really does it always look perfect and make sense? No. But it's a reasonable simulation of people's travel. And these traces are good to be able just to understand the model and see that the point of the model or what it's doing is just generating these tour traces sort of for everybody based on a bunch of estimated models. But then you can also look at these and look through 20 or 30 of them and make sure that they look reasonable and are they producing results that we expect and things like that. So they're good for debugging or understanding the model too. So in the trip-based model then we have all these matrices, right? But in a micro-simulation framework we just have a big table. We have a bunch of tables. We have a table of households, we have a table of persons, we have a table of tours, a table of trips. And we just join, in a database, you'll join those together and say, this person has generated these tours, and these tours have these trips, and we can use all that information a lot more intelligently. So at the end, when you're done, you can say, for example, what kinds of people are going downtown? Well, we will go and look into the tables and say, give me all the trips that are going to the downtown zones, and what are the person's age on those trips, right? So we can do cross queries or tabulations of data like that. That's just not possible in an activity-based model because these matrices are not segmented that way. Activity-based model is good for time of day type questions. So here we're looking at over the hours of the day, the distribution of work trips. So this is people leaving to go to work. This is people coming home from work. And this is non-work travel. So you see a lot more of it. There's more of a PM peak for non-work travel. So in a trip-based model, this is sort of a static input to the model. But this is actually modeled by the activity-based model. So it's sensitive to the inputs that you put into the model. We'll skip that because we're out of time. So, and then the other thing, I guess one other thing to touch on is a lot of the models have TAZs. So that's the all the models have TAZs, the subdivision of space into different areas. But a lot of the newer generation models are starting to subdivide it even further. And so this is an example in San Diego where we have these micro zones where we have about, I think it's about 10 to 1, but we take all the TAZs and we'll look at auto travel between those TAZs. But for walk travel, we'll split the area up into even smaller segments, micro zones. So we'll have 10 micro zones inside the TAZ because walk travel is a lot more sensitive than auto travel, to the distances and things like that, whether you're crossing lakes or things. So if you model walk travel and bike travel at a micro level and nest it within the bigger zones for the auto travel, and you just represent travel a lot better. So those are some big improvements, improvements on the spatial side of the representation. And same thing you can do with parcels. People are also doing it with parcels. You can also model joint travel. Now that we're modeling individuals, we can say if individuals decide to go on travel with everyone in their household, or if they escort people, escort their kid to school and drop them off, we're going to model the kid, we're going to model the parent. Right? So there's thoughts of joint travel, all that type of information is available. So the activity-based model then is a little different than a four-step model, but similar. We take the model inputs, we'll generate the population, we'll do long-term choices like where you work, to do a work location model, mobility choice like how many cars do you own in your household, generate a daily activity pattern for you, meaning do you go to work today or not, do you go to school today, and then generate tours like you'll go to work once, maybe you go to work twice. Then define the number of trips. So for each work tour, do you make stops along the way? Do you go to the grocery store, things like that? Then choose routes for all that information. And then there's feedback loops and things. I'll skip that for now. But and then you get to model outputs and analysis. So for activity-based models, there's much more behavioral realism than in a trip-based model. Much more sensitive to different types of policy questions, pricing, equity, accessibility. The introduction of variability or uncertainty might be a disadvantage in some contexts with an activity-based model, because you can run an activity-based model 30 times and get 30 different answers if you change the random seeds, which is really interesting because you can better understand the distribution of outcomes, right? But in some contexts, 30 different answers is maybe not what everybody wants, right? They want one answer. Maybe it's easier to make decisions. So activity-based models introduce variability and uncertainty to the conversation a lot more than a trip-based model were. It's an advantage, maybe it's a disadvantage. They also take more data. They also are slower to run. But they're really actively being developed in a number of places because they provide such better quality answers to a number of questions that trip-based models struggle with. So travel models, there's a number of different types of travel models, and I've kind of just sort of briefly shown you something about four-step models and something about activity-based models. But there's a whole range of different types of four-step models. Some are simple, some are more complex. It's also true for activity-based models. And I think, and I'm going to guess Rick talked about this last week, that the right model really depends on the questions being asked. You have to earn complexity. So you don't want to use an overly complex tool unless you have to. So it depends on the questions. And so for some of the more traditional questions that the four-step model was answering for the last 20, 30 years, it still does a good job answering those questions. But some of the newer questions, pricing studies, equity questions, land use accessibility questions, activity-based models are maybe better for. And I think that's it. Yep.
Great, thank you.
Yeah.
So now we have time for a few questions. I do have one from over the web, so
Okay.
I thought I'd start with that, which is, what are the typical or average costs of running a travel demand model? And I guess they didn't explicitly say, but I'm interested in money costs as well as time costs.
Well, it depends. I mean, is it a small agency or a large agency? What types of questions are they going to ask? What kind of data do they have available? You need to do a household survey for your region. I mean, it's
The building a model, but here in Portland, if you were running, say, the statewide model, how long does it take to do one model run, approximately?
the statewide model takes a couple days to run. It's a travel model and a land use model and an economic model, and runs for a couple days, and runs in 5-year increments for like 30 or 40 years. So that might be that's a little complicated. A 4-step model runs in a few hours to maybe 10 or 15 hours, depending on the complexity. Some models run in 10 minutes. Yeah. Okay, I guess I get to pick. Go ahead.
Can you give some specific examples, maybe, of an activity-based model that you've run for a client? And who is the client? What question are they trying to answer? And what are they doing with the information you give them?
The different questions that have come up with activity-based models. Well, one question that we worked on here in Oregon was to generate. So there's the statewide model, and it has an activity-based model component in it, a microsimulation of travel. And then they have these 4-step models for the different regions in the state. So for like the Salem MPO, they have a 4-step model, or the Corvallis Albany area, they have a model. And they want to know, they want to generate the external travel for their region. So they want to know who's coming and going through the region, who comes into the model area, who comes to Salem for work or shopping, who goes out in the morning, for work, who drives through the region on I-5. So we're able to use the statewide model and the activity-based model and the statewide model to generate that information for the locals. Yeah.
So you mentioned that activity-based models. Yes. You mentioned that activity-based models can look at the mode someone uses, say, to get to work, and then use that to decide with their trips within there that they take from work, that they could say, well, if they took public transit to work, then they wouldn't be driving. So what that triggered in my mind was car sharing. So I'm curious if you've seen any developments of integrating car sharing into modeling, if that's early or if there's anything
Yeah.
there.
Yeah, so it's coming to models soon, but it's not there yet. Because so far, I think, there's a few reasons maybe. One, there hasn't been a lot of data on car sharing in order to estimate models. We've done travels, primarily we use the household travel survey to estimate the model on the likelihood of choosing certain modes. And so the prevalence of car sharing in travel surveys is probably very, very tiny still. So there's not much data to bite onto to come up with a statistical relationship. But it is developing more, and so I think, and it's a policy question maybe that agencies will want to look at. So I think it'll get in there. Then there's some things that'll have to happen on the back end of the model to be able to share cars and keep track of cars and decide when they're available for your trip and when they're not, and other things that'll have to happen. But it seems like it's an area that models will tackle. Yeah.
I was curious what the models, and maybe this isn't directly what they're for, but what they say about land use and usage of the transportation network. For instance, like, do the models say that people that live downtown might use less of the network, or in higher density urban areas might use less, or do they use more? And do the modes that they choose cost less than, say, out in a low density suburb?
Mm-hmm. So yes, they do. They are sensitive to land use characteristics, densities, accessibilities, things like that. There's a whole range of models. So some are not very sensitive, and others are. But the more advanced models are sensitive to those types of things. And travel models are also integrated sometimes with land use models that model more of that type of information. And that's another area where there's some sensitivities, I guess.
Why is decision-making theory only being used for mode choice?
So in a 4-step model, the mode choice problem is usually formulated as a utility maximization logit model. And the other models are not really like behavioral econometric models. They're just like, how many trips do I generate? How much travel do I make in a day? I look at the survey and it says 9.5, so it's 9.5. It's not a behavioral model, it's just a number.
She asked what was the personal preference was for the models, for your preference.
To make,
I'm saying
to
this for
build?
the people.
I think both of them. You asked for a preference. I didn't give you one, but it depends on. Yeah, I mean, I think the activity-based models. The activity-based models are a little bit easier to understand. I mean, it makes sense. We just generate a whole bunch of people, and then we generate travel for them. They kind of get more complicated, which is kind of fun. But sometimes they're overkill for certain questions. So sometimes four-step models make sense. So it just kind of depends. Yeah.
Which model has a better validation with the actual people's behavior?
I think that activity-based models tend to do better validate. They're validated against different things, and all models usually end up validating pretty well. But that's not really the whole story. Activity-based models look at a lot more things and model a lot more dimensions. And so they're harder to validate and calibrate because they're looking at more dimensions of information. But they are calibrated to those dimensions, just like the four-step models, which are validated and compared against their dimensions of information. So I do think activity-based model does a better job of modeling travel.
Do you think that activity-based models will become commonplace or the standard at maybe middle to large MPOs? And if so, how long do you think that'll take?
Yeah, that's a hot topic. Good question. It seems that they will. There's more and more interest in the next generation models at medium-sized MPOs, but there also there also is some skepticism out there because a lot of questions that smaller agencies are answering and that are asked, that smaller agencies are answered pretty well with their four-step models. So they're interested in the newer models, but they might not be getting the questions, or maybe they're only getting 1 out of 10 questions that a new model could answer, and then they have to decide, is it worth the effort and learning new skills and things. But it does seem like over time they will more and more replace the four-step models.
Great. I think we are out of time.
Okay.
Thanks, Ben, for another
Thanks.
interesting seminar. So we'll see you all here next week.